What's the big deal about removing methane from the atmosphere? Every molecule of methane in the atmosphere today is contributing around 120 times the global warming potential of CO2. Unfortunately, methane is an unusually inert volatile organic compound, or VOC, with a half-life in the atmosphere of 8 to 9 years before it breaks down. Therefore, if artificially produced iron 3 chloride aerosol can work well as a photocatalytic methane removal medium, as we think it will, with only co-benefits for nature, it'll represent a breakthrough for tackling climate change. Professor Matt Johnson explains.
When you put iron chloride into an aerosol, several things are going to happen very quickly. This tiny droplet is going to evaporate, and you'll be left with a nucleus that might pick up some water from the atmosphere. And chemistry is going to start happening, and it's going to change the species that absorbs light. And so we end up with iron oxide, depending on the pH and so on, but this is the chromophore that you're working with. Then it absorbs sunlight, and that's actually fortunate because iron oxide is better able to match the spectrum coming from the sun. And then you're able to convert chloride into elemental chlorine. So this is coming off of the droplet, and then that can react with methane, and it reacts very quickly. And one of my earlier inventions was a method of removing VOCs using the hydroxyl radical. And so we've made a company that does this. When you make windmill blades, that makes a lot of styrene air pollution. And so we're putting these on windmill blade factories. And I had thought of using that approach for methane. And the problem is that methane is so stable, it just doesn't react. And this is the reason it has such a long atmospheric lifetime compared to other kinds of VOC. So other hydrocarbons in the atmosphere, maybe they last for weeks or months. Why should methane be 9 years, right? It's because it's very inert. Now, it turns out because of the oddities of chemical physics, that chlorine has a very fast reaction rate with methane. So it's vulnerable to this kind of attack. And so I think it's a wonderful, and so, you know, France has done a lot of work in pioneering this idea that we could use the chlorine atoms to address this problem.